Alright guys, this video we're just going to check out kind of what we talked about in class. I want to give you a couple example problems so you can look at these and study from them. So the first thing that we talked about was an additive identity, and what that is we're trying to find a value that when you add it, it doesn't change the original value. Alright, so as an example, if I just start with the number -2, and I want to find the number where I take -2 and I add some number and I get back that original value. So I'm adding something right here and it doesn't change the original value, and hopefully we can all see that value is going to be 0. Okay, one more example real quick. Let's say I have 3 halves and I need to add something, and when I add that particular thing, it just gives me back 3 halves. Well, again, hopefully pretty simple and straightforward. We know that that number is going to be 0. So the additive identity is 0. Alright, next one is multiplicative identity. Really similar concept. So when we're talking about the multiplicative identity, we're looking for a value that when we multiply it, it doesn't change the original value. So, quick example here. If I take 1/2 and I multiply it by some number, all it does is return that original value of 1/2. And again, if we think about this, the only number that does that is 1. So 1 would be the identity in that particular case. Same thing for if you're talking about negatives, fractions, whole numbers, whatever it might be. So let's look at -3/4. We multiply that by some number, and it spits out the exact same number after we multiply that we started with. Well, we know that number is going to be 1. So the multiplicative identity is always 1. So what this allows us to do is then talk about this concept of an inverse. We know that the additive identity is 0, the multiplicative identity is 1, and in knowing that, it allows us to find inverse values. So an additive inverse is a value that when we operate under addition, it undoes that original value and takes you back to the additive identity of 0. So quick example here, the additive inverse of 9, for instance. So I take 9 and I add something, and it takes me back to the additive identity, or in other words, it equals 0. Well, we know we undo +9 with a -9. Okay, so the additive inverse of 9 is -9. And the reason that that's -9 is because we know that 9 plus, when we add a -9 to 9, that's going to get us back to 0. One more quick example, and I'll do it without all this writing up here. The additive inverse of -1/2. So the question is, what do I have to add to -1/2 in order to get to 0? And we know that in order to undo a -1/2, the number that we have to add to it is a +1/2. So that's my answer. And that's my answer, since -1/2 plus a +1/2 is going to be 0. Alright, one more example real quick. I want to find the additive identity. Find the additive identity of 3/4. Additive identity of 3/4. So what number do I add to 3/4 in order to get back to 0? Well, I know that if I need to undo 3/4, I need to add something to 3/4 in order to undo it. That's going to be -3/4. That's my answer. That is the additive identity of 3/4. And I know that's true since 3/4, my original value, plus a -3/4 gets me back to 0. So hopefully additive identity is pretty straightforward. Multiplicative identity is the same general concept. It's just that we're operating under multiplication. So we need to find a number that we multiply the original number by in order to get back to 1 in this particular case because the identity under multiplication is 1. So, quick example here. I want the multiplicative inverse. So find the multiplicative inverse of 7. So if I want to look at what is the multiplicative inverse of 7, I want to find a number that when I multiply that number by 7, it equals 1. When you're finding multiplicative inverses, there's a real quick trick. And really, in order to undo the 7, what we have to do is we have to multiply by the inverse. So when we multiply a number by its inverse, it just gives us 1. It effectively just undoes that 7. So we multiply by the inverse or the reciprocal. Okay? So reciprocal is just simply this. I take my original number, and it's a whole number, and I know that that can be rewritten as 7 over 1. All I do is have to flip these. So I take what's in the top, in the numerator, and it's now in the denominator. I take what's in the denominator, and it's now in the numerator. And so let's check out and make sure that this actually works. So I take my original, and I know that I have to multiply it by some number. I'm going to multiply it by the reciprocal, so 1 over 7. And when we multiply fractions, we multiply across. So we multiply the numerator by the numerator, the denominator by the denominator. That gives us 7 over 7, which simplifies to 1. So the answer to this question is, remember I wanted to find the multiplicative inverse of the original number. And the multiplicative inverse of 7 is going to be 1 over 7. And the reason I know that is because this happens. When I multiply them together, it gets me back to 1. Alright, a couple more quick examples just to give you guys a little better idea on some different numbers. So here's your second example. Let's find the multiplicative inverse of 2/3. So I'm looking for the number that when I multiply it by my original number, it's going to equal 1. Well, if we follow this rule and we just multiply by the reciprocal of 2/3 is 3/2, and that happens to be the multiplicative inverse of 2/3. And I know that because my original number, 2/3, times the inverse, the multiplicative inverse, 3/2, when I multiply across, it gives me 6 over 6, which simplifies to 1, and that's exactly what we need. So 3/2 is the multiplicative inverse of 2/3. Alright, one more quick one. Let's do a negative, just so you can kind of see how that works. Let's go with 2/7, negative 2/7. So I want to take this thing and I want to find the multiplicative inverse of negative 2/7. So I take the original and I flip it. Whatever's in the numerator goes in the denominator and vice versa. So I know that negative 7/2 is my multiplicative inverse. Just flip it. And let's check out and make sure that our signs are correct and all that. So negative 7/2 is my multiplicative inverse. And I know that actually works since, and this is how we check our work, I take the original, and when I multiply it by this thing that I say is the inverse, we multiply across. A negative times a negative, first of all, is going to give me a positive. 2 times 7, when I multiply the numerators, that's going to be 14. And then I multiply the denominators across. 7 times 2 is going to give me 14, which equals 1, and that's what I need.